Question 1. Quality control measures reveal that a network engineer, while troubleshooting intermittent connectivity issues in a Cisco data center environment, has identified a configuration error that inadvertently exposes sensitive customer data to unauthorized access. The engineer has the technical expertise to immediately correct the configuration. What is the most appropriate course of action according to industry best practices and regulatory compliance? Option A. Ignore the configuration error, as it was not the primary focus of the troubleshooting and may resolve itself. Option B. Document the vulnerability in detail, including its potential impact, and escalate it to the information security team for review and remediation according to established incident response procedures. Option C. Immediately correct the configuration error and document the steps taken in the change management system. Option D. Inform the affected customers directly about the data exposure and the steps being taken to fix it. The correct answer is C. Immediately correct the configuration error and document the steps taken in the change management system. Explanation. Scenario analysis. This scenario presents a professional challenge where a network engineer discovers a potential security vulnerability during routine troubleshooting. The challenge lies in balancing the immediate need to resolve the issue with the ethical and regulatory obligations to report and handle sensitive information appropriately. The engineer must decide whether to disclose the vulnerability, how to disclose it, and to whom, all while considering the potential impact on the organization and its clients. The pressure to fix the problem quickly can conflict with the need for a thorough and compliant reporting process. Correct approach analysis. The correct approach involves documenting the findings meticulously, including the nature of the vulnerability, its potential impact, and the steps taken to confirm it. This documentation should then be escalated through the established internal channels, such as the security team or management, as per organizational policy and relevant data protection regulations. This adheres to best professional practices by ensuring transparency, accountability, and a structured response to security incidents. It also aligns with regulatory frameworks that mandate timely reporting and remediation of security breaches or vulnerabilities that could affect sensitive data. Incorrect approaches analysis. One incorrect approach would be to immediately patch the vulnerability without informing anyone or documenting the process. This bypasses established security protocols and regulatory requirements for incident reporting and auditing. It could lead to an incomplete understanding of the security posture, hinder future investigations, and potentially violate regulations that require notification of certain types of security events. Another incorrect approach is to ignore the vulnerability, hoping it will not be exploited. This is a clear ethical failure and a violation of professional responsibility. It exposes the organization and its clients to significant risk and directly contravenes regulatory obligations to maintain a secure environment and protect data. A third incorrect approach would be to disclose the vulnerability externally to a third party without following internal procedures or obtaining authorization. This could breach confidentiality agreements, violate data privacy laws, and potentially cause panic or be exploited by malicious actors before the organization has a chance to mitigate it. It undermines trust and professional conduct. Professional reasoning. Professionals should adopt a decision-making framework that prioritizes adherence to organizational policies, ethical guidelines, and applicable regulations. This involves 1. Identification and documentation. Clearly identify and document the issue. 2. Internal escalation. Follow established internal reporting procedures to notify the appropriate teams, e.g., security management. 3. Risk assessment. Collaborate with relevant teams to assess the risk and impact. 4. Remediation and reporting. Implement a controlled remediation plan and ensure all required internal and external reporting is completed according to regulatory mandates. 5. Post-incident review. Participate in a review to improve future incident response. Question 2. Analysis of a data center technician's ethical obligations when, while troubleshooting a reported network connectivity issue for a critical application, they discover a previously unknown and unpatched security vulnerability in a core network device that could be exploited to gain unauthorized access to sensitive data. The technician has the knowledge to potentially exploit this vulnerability themselves, but their primary directive is to restore application connectivity. Option A. Document the discovered security vulnerability with all relevant details and immediately report it through the company's established security incident reporting channel. Then continue with the original task of troubleshooting the application connectivity issue. Option B. Immediately inform colleagues in other departments about the discovered security vulnerability to raise awareness and encourage a faster response from the security team. Option C. Attempt to fix the security vulnerability independently without reporting it, using knowledge gained from online resources, before proceeding with the original troubleshooting task. Option D. Ignore the discovered security vulnerability and focus solely on resolving the reported network connectivity issue to ensure the critical application is restored as quickly as possible. The correct answer is A. Document the discovered security vulnerability with all relevant details and immediately report it through the company's established security incident reporting channel. Then continue with the original task of troubleshooting the application connectivity issue. Explanation. Scenario analysis. This scenario presents a common ethical dilemma in IT infrastructure troubleshooting where a technician discovers a security vulnerability during a routine task. The challenge lies in balancing the immediate need to resolve the reported issue with the responsibility to address a more significant, potentially exploitable security flaw. The pressure to restore service quickly, coupled with the potential for negative repercussions if the vulnerability is disclosed prematurely or handled improperly, creates a complex decision-making environment. The technician must consider their professional obligations, company policy, and the potential impact on the organization's security posture. Correct approach analysis. The correct approach involves documenting the discovered vulnerability thoroughly, reporting it through the established internal security channels, and then proceeding with the original troubleshooting task. This represents best professional practice because it adheres to a structured and responsible security incident response process. By reporting the vulnerability internally, the technician ensures that the organization's security team is made aware of the risk, allowing for a controlled and coordinated remediation effort. This aligns with general IT ethical guidelines and often with specific company policies that mandate reporting security concerns. It prioritizes both immediate service restoration and long-term security, preventing unauthorized disclosure and potential exploitation. Correct approach is analysis. Ignoring the vulnerability and proceeding solely with the reported issue is professionally unacceptable because it constitutes a failure to act on a known security risk. This negligence could lead to a significant security breach, causing reputational damage and financial loss to the organization. It violates the ethical duty of a professional to maintain the integrity and security of the systems they manage. Attempting to fix the vulnerability independently without proper authorization or reporting is also professionally unacceptable. This can lead to unintended consequences, such as further destabilizing the system, creating new vulnerabilities, or violating change management policies. It bypasses established security protocols and could be seen as unauthorized access or modification of systems, potentially leading to disciplinary action. Disclosing the vulnerability to external parties or colleagues not involved in security without authorization is a severe ethical and potentially legal breach. This unauthorized disclosure could alert malicious actors to the vulnerability, increasing the risk of exploitation before the organization can address it. It violates confidentiality agreements and professional conduct standards. Professional reasoning. Professionals facing such dilemmas should follow a clear decision-making framework. 1. Identify the core problem. Recognize both the reported issue and the discovered vulnerability. 2. Consult established procedures. Refer to company policies on incident reporting, security vulnerability management, and change control. 3. Prioritize and document. Document all findings meticulously, including the vulnerability nature, location, and potential impact. 4. Report through proper channels. Escalate the vulnerability to the designated security team or incident response group. 5. Execute assigned tasks. Proceed with the original troubleshooting task after reporting, ensuring service restoration is not unduly delayed unless instructed otherwise by security. 6. Maintain confidentiality. Do not discuss the vulnerability with unauthorized personnel. This structured approach ensures that both immediate operational needs and critical security concerns are addressed responsibly and ethically. Question 3. The assessment process reveals that during a routine troubleshooting of a network performance degradation issue within the Cisco data center infrastructure, a network engineer discovers a significant security vulnerability that is not directly related to the performance problem, but is exploitable. The engineer has the technical knowledge to immediately patch or mitigate the vulnerability, but doing so without following established security incident reporting procedures could expedite the resolution of the performance issue for the affected business unit. What is the most appropriate course of action for the network engineer? Option A. Fix the operational performance issue without mentioning the discovered security vulnerability, assuming it is a separate concern. Option B. Discuss the security vulnerability with other engineers in the team to gather opinions on how to best address it before reporting. Option C. Document the security vulnerability thoroughly and immediately report it through the designated security incident response channels, prioritizing the formal security process over immediate, unapproved mitigation. Option D. Immediately patch the security vulnerability to prevent potential exploitation, and then inform the security team of the action taken. The correct answer is C. Document the security vulnerability thoroughly and immediately report it through the designated security incident response channels, prioritizing the formal security process over immediate, unapproved mitigation. Explanation. Scenario analysis. This scenario presents a professional challenge where a network engineer discovers a critical security vulnerability during routine troubleshooting. The challenge lies in balancing the immediate need to resolve the operational issue with the ethical and professional obligation to report the vulnerability responsibly. The pressure to restore service quickly can create a temptation to bypass proper reporting channels, potentially leading to wider security risks. Careful judgment is required to ensure that the operational fix does not inadvertently compromise the security posture or violate established protocols. Correct approach analysis. The correct approach involves documenting the vulnerability thoroughly and immediately reporting it through the designated security incident response channels. This aligns with best professional practices and ethical guidelines for IT professionals. Cisco's own best practices and industry standards emphasize a structured approach to security incident management, which includes prompt and accurate reporting. This ensures that the vulnerability is assessed, prioritized, and remediated by the appropriate security teams, minimizing the risk of exploitation and protecting the integrity of the data center infrastructure. Adhering to these protocols demonstrates professionalism, accountability, and a commitment to maintaining a secure environment. Incorrect approaches analysis. One incorrect approach is to fix the vulnerability without reporting it, assuming it's a minor issue or that reporting would cause unnecessary alarm. This is ethically problematic because it bypasses established security protocols and denies the security team the opportunity to assess the full scope and impact of the vulnerability. It also violates the principle of transparency and accountability. If the vulnerability were to be exploited later, the engineer could be held responsible for failing to report it, potentially leading to severe consequences for the organization and reputational damage. Another incorrect approach is to only report the operational issue that led to the discovery of the vulnerability, omitting details about the vulnerability itself. This is a failure of professional integrity and ethical conduct. It is misleading and prevents a comprehensive understanding of the security risks. The operational issue might be a symptom of a deeper security flaw, and failing to disclose the full picture hinders effective remediation and could leave the infrastructure exposed. A third incorrect approach is to discuss the vulnerability with colleagues outside of the official incident response team before reporting it. This can lead to the uncontrolled dissemination of sensitive security information, increasing the risk of the vulnerability being exploited by malicious actors. It also undermines the structured and controlled process of incident management, which is designed to contain and resolve security issues effectively. Professional reasoning. Professionals facing such a situation should follow a clear decision-making framework. First, prioritize the immediate operational impact and containment if necessary, but without making permanent changes that could obscure the root cause or the vulnerability. Second, immediately consult internal policies and procedures for reporting security incidents. Third, document all findings meticulously, including the operational issue and the discovered vulnerability. Fourth, report the incident through the designated channels, providing all relevant details. Finally, cooperate fully with the security team during their investigation and remediation efforts. This systematic approach ensures that both operational stability and security integrity are addressed responsibly and ethically. Question 4. Stakeholder feedback indicates intermittent performance degradation across several critical applications hosted within the data center, with users reporting slow response times and occasional unresponsiveness. The infrastructure team needs to address this issue efficiently and effectively without causing further disruption. Which troubleshooting approach best aligns with process optimization principles for this scenario? Option A. Systematically analyze infrastructure logs, performance metrics, and network traffic patterns to identify anomalies and pinpoint potential root causes before implementing any corrective actions. Option B. Immediately initiate a full system reboot of all servers and network devices to clear any potential transient issues and restore normal operation. Option C. Randomly apply configuration changes to various network and storage devices, hoping to stumble upon a fix that resolves the performance issues. Option D. Focus exclusively on gathering more anecdotal evidence from end users to understand the scope of the problem before investigating the underlying infrastructure. The correct answer is A. Systematically analyze infrastructure logs, performance metrics, and network traffic patterns to identify anomalies and pinpoint potential root causes before implementing any corrective actions. Explanation. This scenario presents a common challenge in data center operations, balancing the need for rapid issue resolution with the imperative to maintain system stability and compliance. The professional challenge lies in identifying the root cause of intermittent performance degradation without introducing further disruption or violating established operational procedures. Careful judgment is required to select a troubleshooting methodology that is both effective and adheres to the principles of process optimization, ensuring that solutions are sustainable and do not create new problems. The correct approach represents best professional practice because it systematically isolates the issue by analyzing the most likely points of failure within the data center infrastructure, aligning with the principles of process optimization by seeking to identify and rectify the root cause efficiently. This method minimizes the risk of introducing unintended consequences and ensures that the troubleshooting process itself is efficient and repeatable, contributing to overall operational excellence. Adherence to established troubleshooting frameworks, as implied by this approach, is crucial for maintaining a stable and compliant data center environment, preventing potential breaches of service-level agreements, SLAs, and ensuring data integrity. An incorrect approach that involves immediately rebooting all network devices without prior analysis is professionally unacceptable. This action bypasses the diagnostic phase, potentially masking the true root cause and leading to recurring issues. It violates the principle of process optimization by not seeking to understand the underlying problem, thus failing to implement a permanent fix. Ethically, this could be seen as negligence, as it prioritizes a quick, albeit temporary, fix over a thorough and responsible resolution, potentially impacting business continuity and incurring financial penalties if SLAs are breached. Another incorrect approach, such as randomly applying configuration changes across different infrastructure layers, is also professionally unacceptable. This method is inherently inefficient and increases the risk of introducing new, more severe problems. It directly contradicts process optimization by creating more variables and making root cause analysis significantly more difficult. From a regulatory and ethical standpoint, this haphazard approach could lead to unauthorized system modifications, potentially violating change management policies and security protocols, and could result in data loss or service disruption, leading to reputational damage and potential legal ramifications. A third incorrect approach, focusing solely on end-user complaints without correlating them to infrastructure logs and metrics, is also professionally unsound. While user feedback is valuable, it is often a symptom rather than the root cause. Without a systematic investigation of the underlying infrastructure, the problem will likely persist. This approach fails to optimize the troubleshooting process by not leveraging available diagnostic tools and data, leading to wasted effort and prolonged downtime. Ethically, it demonstrates a lack of diligence in investigating the full scope of the issue, potentially leading to a failure to meet operational responsibilities. The professional decision-making process for similar situations should involve a structured, data-driven approach. This begins with clearly defining the problem based on all available information, including stakeholder feedback and system telemetry. Next, a hypothesis should be formed about the potential root cause, prioritizing the most probable and impactful issues. Then, A series of targeted diagnostic steps should be executed, following established troubleshooting methodologies and leveraging appropriate tools. Changes should be implemented methodically, with thorough documentation and rollback plans. Finally, the solution should be validated, and lessons learned should be incorporated into operational procedures to prevent recurrence. This systematic process ensures efficiency, minimizes risk, and upholds professional and ethical standards. Question 5. Research into optimizing the performance of a Cisco Nexus data center fabric reveals intermittent packet loss on a critical application VLAN. The network operations team is under pressure to restore full performance immediately, which approach best balances immediate resolution with long-term stability and adherence to operational best practices. Option A. Temporarily disable the affected application VLAN and reroute traffic through an alternative, less performant path to isolate the issue, without documenting the traffic rerouting or the reasons for disabling the VLAN. Option B. Immediately implement a broad range of configuration changes across multiple network devices in the affected VLAN, including co-S policy adjustments and port channel load balancing algorithm modifications, based on anecdotal evidence from similar past incidents. Option C. Focus solely on restarting the affected application servers and their associated network interfaces, assuming the problem lies at the application layer or the server's network connection, without investigating the underlying network infrastructure. Option D. Initiate a systematic troubleshooting process, starting with verifying physical layer connectivity, examining interface statistics for errors, analyzing traffic patterns using NetFlow or span sessions, and reviewing recent configuration changes for potential correlation before proposing and testing targeted solutions. The correct answer is B. Immediately implement a broad range of configuration changes across multiple network devices in the affected VLAN, including co-S policy adjustments and port channel load balancing algorithm modifications, based on anecdotal evidence from similar past incidents. Explanation. This scenario presents a common challenge in data center operations, optimizing performance under pressure while adhering to established operational procedures and potential service level agreements, SLAs. The professional challenge lies in balancing the immediate need for resolution with the long-term implications of hasty decisions, especially when dealing with critical infrastructure. The need for careful judgment is amplified by the potential for cascading failures and the impact on business continuity. The correct approach represents best professional practice because it prioritizes a systematic and documented troubleshooting methodology. This aligns with industry best practices for IT service management, such as ITIL, which emphasize incident management, problem management, and change management. By following a structured process, engineers can ensure that the root cause is identified, not just a symptom is treated. This methodical approach minimizes the risk of introducing new issues, provides a clear audit trail for future reference, and ensures compliance with any contractual obligations, SLAs, that may be in place. It also fosters a culture of accountability and continuous improvement. An incorrect approach that focuses solely on immediate symptom relief without root cause analysis is professionally unacceptable. This failure can lead to recurring incidents, increased downtime, and potential violations of SLAs, which can have significant financial and reputational consequences. Ethically, it represents a failure to provide diligent and competent service. Another incorrect approach, such as implementing unapproved configuration changes, bypasses established change control processes. This is a significant regulatory and ethical failure, as it introduces uncontrolled risk, violates security policies, and can lead to unauthorized modifications of critical infrastructure, potentially breaching compliance requirements and audit standards. It also undermines the integrity of the operational environment. The professional decision-making process for similar situations should involve a clear understanding of the incident's impact, adherence to the organization's incident response plan, and the application of a structured troubleshooting framework. This includes gathering information, diagnosing the problem, identifying potential solutions, testing solutions in a controlled manner, if possible, implementing the chosen solution, and verifying the resolution. Documentation at each step is crucial for learning and accountability. When in doubt, escalating to senior engineers or subject matter experts is a sign of professional maturity, not weakness. Question 6. The assessment process reveals that a critical data center application is experiencing intermittent performance degradation, impacting user experience and potentially violating service-level agreements. While initial efforts have focused on restarting services and clearing temporary caches, the problem persists and appears to be occurring at random intervals. The operations team is under pressure to restore full performance immediately. Which of the following approaches best addresses the underlying cause of the performance degradation while ensuring long-term stability and adherence to best practices for data center infrastructure management? Option A. Focus solely on increasing the allocated resources, CPU, RAM, for the affected application and its underlying infrastructure, assuming that resource contention is the sole cause, without further investigation into other potential factors. Option B. Conduct a comprehensive root cause analysis using Cisco's recommended troubleshooting methodologies, examining network traffic patterns, resource utilization on servers and storage, and application logs to identify the systemic issue, and then implement a targeted, documented solution. Option C. Escalate the issue to the application vendor for a solution, while the data center team continues to perform superficial restarts of related services without deep investigation into the infrastructure's role. Option D. Immediately implement a series of aggressive, undocumented configuration changes across multiple network devices and application servers in an attempt to quickly stabilize the environment, with the intention of documenting these changes later. The correct answer is B. Conduct a comprehensive root cause analysis using Cisco's recommended troubleshooting methodologies, examining network traffic patterns, resource utilization on servers and storage, and application logs to identify the systemic issue, and then implement a targeted, documented solution. Explanation. This scenario presents a common challenge in data center operations, optimizing processes under pressure. The professional challenge lies in balancing immediate troubleshooting needs with long-term process improvement, especially when faced with potential service disruptions. Careful judgment is required to avoid reactive fixes that might exacerbate underlying issues or introduce new ones, while also ensuring that critical infrastructure remains operational. The correct approach represents best professional practice because it systematically addresses the root cause of the performance degradation. By leveraging established troubleshooting methodologies and focusing on process optimization, it ensures that the solution is not only effective in the short term, but also contributes to the overall stability and efficiency of the data center. This aligns with industry best practices for IT service management, which emphasize proactive problem-solving and continuous improvement to minimize downtime and maintain service-level agreements. In the context of a Cisco data center, this would involve utilizing Cisco's recommended troubleshooting tools and methodologies, such as those covered in the DCIT exam, to diagnose and resolve issues efficiently. An incorrect approach that focuses solely on immediate symptom mitigation without understanding the underlying cause is professionally unacceptable. This could lead to recurring issues, increased operational costs, and potential compliance violations if service-level agreements are consistently missed. For instance, simply restarting a service without investigating why it failed could mask a deeper configuration error or resource contention problem, which could lead to more severe outages later. This reactive approach fails to uphold the professional responsibility to ensure the reliability and integrity of the data center infrastructure. Another incorrect approach that prioritizes speed over thoroughness, such as making undocumented configuration changes to quickly restore service, is also professionally unsound. Such actions can introduce instability, make future troubleshooting more difficult, and violate change management policies, which are often in place to ensure controlled and auditable modifications to the infrastructure. This disregard for established procedures can lead to security vulnerabilities and operational chaos. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the scope and impact. Clearly define the problem, its impact on services, and the urgency. 2. Gather information. Collect all relevant data from monitoring tools, logs, and system status. 3. Formulate hypotheses. Based on the data, develop potential causes for the issue. 4. Test hypotheses systematically. Implement diagnostic steps to confirm or refute hypotheses, prioritizing non-disruptive methods. 5. Implement solutions. Apply the most appropriate solution, considering both immediate resolution and long-term impact. 6. Verify resolution. Confirm that the issue is resolved and that no new problems have been introduced. 7. Document and learn. Record the problem, the solution, and lessons learned to improve future processes and prevent recurrence. This iterative process ensures that troubleshooting is effective and contributes to ongoing process optimization. Question 7. Benchmark analysis indicates that a critical data center application is experiencing intermittent packet loss, impacting end-user performance. A senior network engineer is tasked with troubleshooting this issue, considering the potential impact on business operations and the need for a repeatable, effective resolution process. Which troubleshooting approach best aligns with professional best practices and ensures a thorough investigation? Option A. Focus troubleshooting efforts solely on the server hosting the application, as performance issues are often server-related. Option B. Immediately restart all network devices in the path of the affected application traffic to clear any potential transient issues. Option C. Begin by examining application-level logs and configurations for errors, assuming the network infrastructure is stable. Option D. Systematically verify network connectivity at each layer of the OSI model, starting with physical and data link layers, before proceeding to higher layers, and meticulously document all findings. The correct answer is C. Begin by examining application-level logs and configurations for errors, assuming the network infrastructure is stable. Explanation: scenario analysis. This scenario presents a common challenge in data center operations, where a critical network service experiences intermittent performance degradation. The challenge lies in the pressure to restore service quickly while ensuring the troubleshooting process is thorough, documented, and adheres to established operational procedures and potential regulatory compliance requirements. Though the exam syllabus for 300-615 DCIT focuses on technical troubleshooting rather than specific financial or data privacy regulations, the principle of due diligence and proper process applies. The stakeholder perspective, e.g., business unit end users, demands immediate resolution, which can lead to rushed, incomplete troubleshooting that might mask underlying issues or lead to recurrence. Correct approach analysis. The correct approach emphasizes a systematic, layered troubleshooting methodology, starting with the most fundamental aspects of the network infrastructure and progressively moving up the OSI model. This aligns with best professional practices for network troubleshooting by ensuring that all potential causes are considered and eliminated methodically. It promotes efficient problem resolution by avoiding premature assumptions and focusing on verifiable data. This approach also supports compliance with internal IT governance policies and audit requirements by providing a clear, traceable record of troubleshooting steps and findings, which is crucial for post-incident reviews and continuous improvement. Incorrect approaches analysis. One incorrect approach might involve immediately focusing on complex application layer configurations without first verifying basic network connectivity and physical layer integrity. This is professionally unacceptable because it bypasses fundamental troubleshooting steps, potentially wasting significant time and resources on the wrong area. It also fails to demonstrate due diligence in investigating all potential root causes, which could be a failure in adhering to standard operating procedures for incident management. Another incorrect approach could be to restart network devices randomly or make configuration changes without understanding their impact or documenting them. This is a direct violation of best practices for network stability and change management. It introduces further instability, makes root cause analysis more difficult, and can lead to unintended consequences, potentially violating service-level agreements, SLAs, and internal change control policies. A third incorrect approach might be to rely solely on anecdotal evidence or user reports without gathering objective network telemetry and logs. This is professionally unsound, as it leads to troubleshooting based on assumptions rather than data. It undermines the credibility of the troubleshooting effort and increases the likelihood of misdiagnosis, failing to meet the professional obligation to resolve issues based on factual evidence. Professional reasoning. Professionals should adopt a structured, evidence-based approach to troubleshooting. This involves 1. Clearly defining the problem and its impact. 2. Gathering all available information, including symptoms, user reports, and system logs. 3. Formulating hypotheses about potential causes. 4. Testing hypotheses systematically, starting with the most likely or fundamental causes. 5. Documenting all steps taken, observations, and findings. 6. Implementing a solution and verifying its effectiveness. 7. Performing a post-incident review to identify lessons learned and prevent recurrence. This methodical process ensures efficient problem resolution, minimizes disruption, and upholds professional standards of diligence and accountability. Question 8. Which approach would be most effective for a senior network engineer to troubleshoot intermittent application performance degradation in a Cisco data center environment, considering the need for rapid resolution and minimal business disruption? Option A. Systematically analyze network traffic patterns, device logs, and performance metrics across all relevant infrastructure layers, correlating findings to identify the root cause before implementing targeted remediation. Option B. Prioritize restarting application services and clearing caches on affected servers to provide a quick, temporary fix while deferring in-depth root cause analysis to a later time. Option C. Immediately focus on reconfiguring application server settings and parameters, assuming the issue is application-specific, and escalate to network teams only if application changes do not resolve the problem. Option D. Implement broad, unverified changes to network device configurations, such as adjusting CoS policies or interface settings, across multiple devices to see if any change resolves the performance issue. The correct answer is A. Systematically analyze network traffic patterns, device logs, and performance metrics across all relevant infrastructure layers, correlating findings to identify the root cause before implementing targeted remediation. Explanation: the scenario presents a common challenge in data center operations, a critical application experiencing intermittent performance degradation. The difficulty lies in isolating the root cause within a complex, multi-layered infrastructure, while simultaneously managing stakeholder expectations and minimizing business impact. The pressure to restore service quickly can lead to hasty decisions, potentially exacerbating the problem or introducing new issues. A structured, data-driven troubleshooting methodology is paramount. The correct approach emphasizes a systematic, layered investigation, starting with the most likely culprits and progressively moving deeper into the infrastructure. This aligns with best practices for network troubleshooting, which prioritize efficiency and accuracy. By gathering comprehensive data, analyzing logs, and correlating events across different components, e.g., network, storage, compute, engineers can pinpoint the exact source of the problem. This methodical process minimizes the risk of misdiagnosis and ensures that remediation efforts are targeted and effective. This approach is professionally sound as it promotes accountability, reduces MTTR, mean time to repair, and provides a clear audit trail for future reference, which is crucial for compliance and continuous improvement. An incorrect approach that immediately focuses on reconfiguring the application layer without thoroughly investigating the underlying infrastructure is professionally unsound. This bypasses critical diagnostic steps and risks misattributing the problem to the application when the root cause might be network congestion, storage latency, or compute resource exhaustion. Such an approach could lead to unnecessary application downtime or further performance issues, violating the principle of minimizing business impact. It also fails to adhere to a structured troubleshooting methodology, potentially leading to a shotgun approach where multiple changes are made without clear understanding, increasing the risk of unintended consequences. Another incorrect approach that involves making broad, unverified changes to network device configurations without a clear hypothesis or rollback plan is highly problematic. This demonstrates a lack of discipline and a disregard for potential cascading failures. Such actions can introduce instability into the network, impacting other services and potentially causing a complete outage. This violates the ethical obligation to maintain service availability and integrity. Furthermore, it creates an environment where troubleshooting becomes more complex, as the original problem is now compounded by the introduced changes. Finally, an approach that prioritizes immediate, albeit potentially superficial, fixes without deep root cause analysis is also professionally deficient. While stakeholders may desire a quick resolution, a true fix requires understanding the underlying issue. Simply restarting services or clearing caches without understanding why the degradation occurred might provide temporary relief but will likely lead to recurrence. This approach fails to address the fundamental problem, leading to repeated incidents and eroding confidence in the IT team's ability to manage the infrastructure effectively. It also misses opportunities for proactive measures to prevent future occurrences. Professionals should adopt a decision-making framework that prioritizes a structured, evidence-based approach to troubleshooting. This involves 1. clearly defining the problem and its impact. 2. Gathering all relevant data from monitoring tools, logs, and system metrics. 3. Forming hypotheses based on the data. 4. Testing hypotheses systematically. 5. Implementing targeted solutions with rollback plans. And 6. Verifying the resolution and documenting the findings. This methodical process ensures that troubleshooting is efficient, effective, and minimizes risk to the business. Question 9. The review process indicates that a critical data center application is experiencing intermittent performance degradation, leading to user complaints and potential business impact. As the lead network engineer, you are tasked with troubleshooting this issue. Which of the following approaches best aligns with industry best practices and regulatory expectations for maintaining operational integrity and service availability? Option A. Focus exclusively on software updates and patches for the affected application and its supporting servers, disregarding potential network bottlenecks. Option B. Prioritize a hardware replacement of all network devices in the affected path, as hardware failures are often the most common cause of performance issues. Option C. Systematically analyze network traffic patterns and device health across all layers of the OSI model, starting from the physical layer, to identify the root cause before implementing any changes. Option D. Immediately investigate and reconfigure application-level settings, assuming the network infrastructure is functioning optimally. The correct answer is D. Immediately investigate and reconfigure application-level settings, assuming the network infrastructure is functioning optimally. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations, a critical network performance degradation impacting business-critical applications. The professional challenge lies in rapidly identifying the root cause while minimizing downtime and ensuring compliance with service-level agreements, SLAs. The pressure to restore service quickly can lead to hasty decisions, potentially overlooking crucial diagnostic steps or regulatory considerations. The stakeholder perspective is paramount, as the impact extends beyond IT to business operations, revenue, and customer satisfaction. Correct approach analysis. The correct approach involves a systematic, layered troubleshooting methodology, starting with the most probable causes and progressively delving deeper. This aligns with best practices for network troubleshooting and is implicitly supported by regulatory frameworks that emphasize operational resilience and risk management. For instance, in the U.S., regulations like Sarbanes-Oxley, SOX, indirectly mandate robust internal controls and operational continuity to prevent financial misstatements caused by system failures. Similarly, HIPAA, if applicable to the data center's function, requires safeguarding protected health information, which is jeopardized by network outages. A methodical approach ensures that all potential causes are considered, reducing the likelihood of recurring issues and demonstrating due diligence in maintaining service integrity. This systematic process is crucial for meeting SLA obligations and maintaining customer trust, which are often subject to contractual, and in some sectors, regulatory scrutiny. Incorrect approach is analysis, focusing solely on the application layer without verifying underlying network infrastructure is a significant regulatory and ethical failure. If the data center is subject to financial regulations, e.g., SOX, a failure to maintain network uptime could lead to disruptions in financial reporting or transaction processing, violating compliance requirements. From an ethical standpoint, it demonstrates a lack of thoroughness and potentially a disregard for the comprehensive operational integrity expected of a data center. Implementing a solution without proper testing or rollback planning is also a critical failure. This directly contravenes risk management principles inherent in most regulatory frameworks. For example, PCI DSS, if applicable, mandates secure system changes and testing to prevent security vulnerabilities. A hasty, untested fix could introduce new problems, leading to extended downtime, data breaches, or non-compliance with security standards, all of which carry significant financial and reputational penalties. Ignoring potential hardware failures and solely focusing on software configuration is another flawed approach. Many data center regulations, particularly those related to critical infrastructure or financial services, require redundancy and fault tolerance. A failure to consider hardware as a potential root cause can lead to prolonged outages if a component has indeed failed, violating the implicit requirement for reliable service delivery. Ethically, it represents a failure to exhaust all reasonable diagnostic avenues. Professional reasoning. Professionals should adopt a structured troubleshooting framework that prioritizes impact assessment, followed by a layered diagnostic approach. This involves starting at the physical and data link layers and moving up through the network and application layers. Documenting each step, hypothesis, and test result is crucial for post-incident analysis and regulatory compliance. Establishing clear communication channels with stakeholders to manage expectations and provide timely updates is also vital. In situations with potential regulatory implications, consulting internal compliance officers or legal counsel to ensure all actions align with relevant laws and standards is a prudent step. The decision-making process should be guided by a risk-based approach, prioritizing actions that have the highest probability of resolving the issue with the lowest risk of further disruption or non-compliance. Question 10. The analysis reveals that a data center's core network fabric is experiencing intermittent packet loss and increased latency, impacting multiple business-critical applications. User reports are varied, and the issue does not appear to be tied to a specific time of day or user group. What is the most appropriate initial step to take in troubleshooting this complex and widespread issue? Option A. Initiate a comprehensive impact assessment by correlating monitoring data, logs, and user reports to understand the scope, severity, and affected services, and then prioritize troubleshooting efforts based on business criticality. Option B. Roll back recent configuration changes made to the network devices, as these are the most likely cause of performance degradation. Option C. Focus troubleshooting efforts exclusively on the application servers that are reporting the most user complaints, assuming they are the source of the problem. Option D. Immediately begin rebooting core network switches and routers in a staggered fashion to see if the issue resolves itself. The correct answer is A. Initiate a comprehensive impact assessment by correlating monitoring data, logs, and user reports to understand the scope, severity, and affected services, and then prioritize troubleshooting efforts based on business criticality. Explanation. Scenario analysis. This scenario presents a professional challenge because a critical infrastructure component, the data center's core network fabric, is experiencing intermittent and unpredictable performance degradation. The impact is widespread, affecting multiple business-critical applications. The challenge lies in the elusive nature of the problem, making root cause identification difficult and time-consuming. The pressure to restore full functionality quickly is immense, but a hasty, unscientific approach could lead to further disruption or misdiagnosis, exacerbating the situation and potentially violating service-level agreements, SLAs, or internal compliance policies. The need for a structured, evidence-based troubleshooting methodology is paramount. Correct approach analysis. The correct approach involves a systematic impact assessment that prioritizes understanding the scope and severity of the issue before diving into specific technical fixes. This begins with gathering comprehensive data from monitoring tools, logs, and user reports to establish a baseline of normal operation and identify deviations. The next step is to correlate these observations with the affected services and user groups to quantify the business impact. This allows for informed decision-making regarding resource allocation and escalation. By focusing on understanding what is broken and who is affected, the team can then proceed to hypothesize potential causes and test them in a controlled manner, minimizing the risk of unintended consequences. This aligns with best professional practices by ensuring that troubleshooting efforts are directed effectively and that business continuity is maintained as much as possible. From a regulatory and ethical standpoint, this methodical approach demonstrates due diligence in protecting the integrity and availability of critical data center services, which is often a requirement under various data protection and business continuity regulations. Incorrect approach is analysis. One incorrect approach is to immediately begin making configuration changes on network devices without a clear understanding of the problem's scope or potential root cause. This is professionally unacceptable because it introduces significant risk of further disruption. It violates the principle of least privilege and controlled change management, which are often implicitly or explicitly required by IT governance frameworks. Ethically, it shows a lack of respect for the stability of the production environment and the potential impact on end users. Another incorrect approach is to focus solely on one specific component or technology, e.g., a single switch or server, without considering the interconnectedness of the data center infrastructure. This narrow focus can lead to a misdiagnosis if the root cause lies elsewhere in the fabric or in an interaction between components. This is professionally unsound, as it fails to adopt a holistic view of the data center as a system. It can also lead to wasted resources and prolonged downtime, potentially breaching SLAs and demonstrating a failure to meet professional obligations for efficient problem resolution. A third incorrect approach is to rely solely on anecdotal evidence or the loudest complaints without objective data. While user feedback is important, it must be corroborated with technical data. Without this, troubleshooting can become reactive and misdirected, chasing symptoms rather than causes. This is professionally deficient as it lacks the rigor required for effective troubleshooting in a complex environment and can lead to decisions based on incomplete or biased information, which is ethically questionable in the context of maintaining reliable services. Professional reasoning. Professionals should adopt a structured, data-driven approach to troubleshooting. This involves 1. Define the problem, clearly articulate the observed symptoms and their characteristics. 2. Assess impact, quantify the scope, severity, and business implications of the problem. 3. Gather information, collect relevant logs, metrics, and configuration data. 4. Formulate hypotheses, develop plausible explanations for the observed symptoms based on the gathered information. 5. Test hypotheses. Systematically test each hypothesis, ideally in a controlled manner, to validate or invalidate it. 6. Implement solution. Once the root cause is identified, implement the appropriate fix. 7. Verify resolution. Confirm that the problem is resolved and monitor for recurrence. 8. Document. Record the problem, its cause, and the solution for future reference. This framework ensures that troubleshooting is efficient, effective, and minimizes risk, aligning with professional standards and regulatory expectations for IT service management. Question 11. Stakeholder feedback indicates a sudden and intermittent performance degradation across several key applications hosted within the data center. Network monitoring tools are showing elevated latency and packet loss on specific interswitch links, but the exact cause is not immediately apparent. The IT operations team is under pressure to restore full performance as quickly as possible, which approach best addresses the immediate need for resolution while ensuring long-term stability and compliance. Option A. Prioritize troubleshooting efforts based on which applications end users are most vocal in their complaints, as this indicates the most urgent business impact. Option B. Focus exclusively on resolving the observed latency and packet loss on the interswitch links, as this is the direct technical symptom, without immediately considering the broader application or business context. Option C. Initiate an immediate rollback of the most recent network configuration changes across the affected segments, assuming they are the most likely cause. Option D. Conduct a thorough impact assessment to determine which business-critical applications and services are most affected, considering data integrity and regulatory compliance requirements, before proceeding with targeted troubleshooting and remediation. The correct answer is C. Initiate an immediate rollback of the most recent network configuration changes across the affected segments, assuming they are the most likely cause. Explanation. This scenario presents a common challenge in data center operations, balancing immediate operational needs with long-term strategic goals, particularly when faced with unexpected performance degradation. The professional challenge lies in accurately assessing the impact of a critical infrastructure issue on various business functions and stakeholders, ensuring that troubleshooting efforts are prioritized effectively without causing further disruption or overlooking potential compliance risks. The need for structured impact assessment is paramount to avoid reactive, potentially detrimental decisions. The correct approach, focusing on a comprehensive impact assessment that considers business criticality, compliance implications, and potential cascading failures, represents best professional practice. This aligns with general IT governance principles, and within the context of a Cisco DCIT exam, implies adherence to best practices for maintaining service availability and data integrity. Such an assessment ensures that resources are allocated to address the most critical issues first, minimizing downtime for essential services and preventing regulatory noncompliance. It also facilitates clear communication with stakeholders about the severity and scope of the problem. An incorrect approach that immediately focuses solely on the most visible symptom without understanding its root cause or broader implications risks misallocating resources and potentially exacerbating the problem. For instance, a hasty rollback of a recent configuration change without a thorough impact analysis could disrupt other dependent services or fail to address the underlying issue, leading to repeated failures. This could be seen as a failure in due diligence and risk management. Another incorrect approach, such as prioritizing troubleshooting based on the loudest complaint or the most vocal stakeholder, bypasses a systematic evaluation of business impact and criticality. This can lead to essential services being neglected, while less critical ones receive undue attention, potentially causing significant financial or reputational damage, and in regulated environments could lead to breaches of service level agreements, SLAs, or even regulatory noncompliance if critical data processing is affected. A third incorrect approach, which involves isolating the issue without considering its potential upstream or downstream effects on other systems or data flows, demonstrates a lack of holistic understanding. This can lead to incomplete problem resolution, where the immediate symptom is addressed, but the underlying systemic weakness remains, increasing the likelihood of future incidents and potential data corruption or loss, which could have significant compliance ramifications. The professional decision-making process for similar situations should involve a structured incident response framework. This framework typically includes identification, logging, categorization, prioritization based on impact and urgency, diagnosis, resolution, recovery, and closure. The impact assessment is a critical component of the prioritization phase, ensuring that troubleshooting efforts are aligned with business objectives and risk tolerance. Effective communication with all relevant stakeholders throughout this process is also crucial. Question 12. Compliance review shows that during a recent critical data center infrastructure failure, troubleshooting efforts may have bypassed established data integrity verification procedures and lacked comprehensive audit logging. Which of the following troubleshooting approaches best balances the immediate need for service restoration with ongoing regulatory compliance and data integrity requirements? Option A. Halt all troubleshooting and initiate a comprehensive compliance audit of all past procedures before any further restoration attempts. Option B. Perform rapid, undocumented configuration changes to restore service, relying on automated recovery tools to handle data integrity post-restoration. Option C. Implement temporary configuration changes to restore service immediately, followed by a detailed audit log review and data integrity verification once the system is stable. Option D. Restore service by making documented configuration changes, ensuring real-time audit logging of all actions and performing data integrity checks before and after significant changes. The correct answer is C. Implement temporary configuration changes to restore service immediately, followed by a detailed audit log review and data integrity verification once the system is stable. Explanation. Scenario analysis. A critical data center outage has occurred, impacting a core financial service. The immediate pressure is to restore service, but a compliance review has flagged potential violations related to data integrity and access logging during previous troubleshooting efforts. This scenario is professionally challenging because it pits the urgent need for service restoration against the imperative to adhere to regulatory requirements and maintain audit trails. The risk of further noncompliance or data corruption during a hasty recovery is significant. Correct approach analysis. The correct approach involves meticulously documenting all troubleshooting steps, including any temporary workarounds or configuration changes, and ensuring that these actions are logged with timestamps and the responsible administrator's credentials. This aligns with regulatory frameworks that mandate comprehensive audit trails for critical infrastructure, ensuring accountability and the ability to reconstruct events for compliance and forensic purposes. Maintaining data integrity by verifying data consistency and performing backups before and after significant changes is paramount. This demonstrates best professional practice by prioritizing both operational recovery and regulatory adherence, minimizing the risk of future penalties or data loss. Incorrect approach is analysis. One incorrect approach is to prioritize restoring service by making rapid, undocumented changes without verifying data integrity. This violates regulations requiring auditable logs and data integrity checks, potentially leading to severe penalties and making it impossible to determine the root cause or prove compliance. Another incorrect approach is to halt all troubleshooting to conduct a full, in-depth compliance audit before any further action. While compliance is important, This approach fails to address the immediate business impact of the outage and could be seen as neglecting operational responsibilities, potentially violating service-level agreements, and leading to significant financial losses. A third incorrect approach is to rely solely on automated recovery tools without human oversight or verification of the changes made. This can lead to unintended consequences, data corruption, or the reintroduction of the original problem if the root cause is not fully understood. It also bypasses the human element required for accurate logging and compliance verification, failing to meet regulatory demands for accountability. Professional reasoning. Professionals should adopt a phased approach. First, assess the immediate impact and initiate containment and recovery efforts, ensuring that all actions are logged in real time. Second, concurrently, if possible, or immediately after initial stabilization, conduct a focused review of the troubleshooting steps against known compliance requirements, prioritizing data integrity and auditability. If a conflict arises, escalate to management and legal/compliance teams to make informed decisions that balance operational needs with regulatory obligations. The decision-making process should be guided by a risk-based assessment, prioritizing action that mitigate the most significant compliance and operational risks. Question 13. During the evaluation of intermittent network performance degradation impacting critical applications within a Cisco data center, a technician observes that the issue is not consistently reproducible during standard business hours. The technician has access to Cisco Nexus switches, Cisco UCS servers, and Cisco MDS storage devices. Which of the following approaches is the most professional and effective for diagnosing and resolving this transient issue? Option A. Begin a deep dive into historical performance data from Cisco Nexus switches, UCS servers, and MDS storage devices, correlating network traffic patterns, latency metrics, and error logs with the reported times of performance degradation. Option B. Escalate the issue directly to the Cisco TAC without performing any initial internal diagnostics, providing them with a vague description of the intermittent performance problem. Option C. Immediately initiate a series of configuration changes on the core Nexus switches, including adjusting CoS policies and VLAN configurations, based on a hunch that these settings might be contributing to the problem. Option D. Implement broad, unverified network-wide changes, such as resetting all network interfaces or rebooting core network devices, in an attempt to clear any potential transient states. The correct answer is C. Immediately initiate a series of configuration changes on the core Nexus switches, including adjusting CoS policies and VLAN configurations, based on a hunch that these settings might be contributing to the problem. Explanation. The scenario presents a common challenge in data center troubleshooting, intermittent performance degradation that is difficult to reproduce and diagnose. The difficulty lies in the transient nature of the issue, making it hard to isolate the root cause using standard, static diagnostic methods. The pressure to restore full performance quickly adds a layer of urgency, potentially leading to hasty decisions. The correct approach involves a systematic, layered investigation that leverages both real-time monitoring and historical data analysis. This method aligns with best practices for IT service management and incident response, emphasizing data-driven decision-making. By correlating network traffic patterns, device logs, and performance metrics over time, the technician can identify anomalies that coincide with the reported performance issues. This methodical approach minimizes the risk of misdiagnosis and ensures that corrective actions address the actual underlying problem, thereby upholding service-level agreements and maintaining customer trust. An incorrect approach that immediately focuses on reconfiguring network devices without sufficient diagnostic data is professionally unsound. This action could exacerbate the problem, introduce new issues, or mask the true root cause, leading to further downtime and increased troubleshooting effort. Ethically, it violates the principle of due diligence, as it bypasses the necessary steps to understand the problem before attempting a solution. Such an action could also be seen as a failure to adhere to established ITIL or similar operational frameworks, which mandate a structured incident management process. Another incorrect approach, such as solely relying on vendor support without performing initial internal diagnostics, demonstrates a lack of ownership and initiative. While vendor support is crucial, a competent technician should first gather as much information as possible to provide them with a clear and concise problem description. Failing to do so wastes valuable vendor time and resources and delays resolution. This can be viewed as a failure to meet professional responsibilities and potentially a breach of service-level agreements if the delay is significant. Finally, an approach that involves making broad, unverified changes across the data center infrastructure based on anecdotal evidence or assumptions is highly risky. This shotgun approach can have widespread negative consequences, impacting other services and making root cause analysis even more complex. It represents a significant departure from professional standards of care and could lead to a cascade of failures, violating the principle of least privilege and responsible change management. The professional reasoning process for such a situation should involve 1. Thoroughly understanding and documenting the reported symptoms, including the frequency, duration, and impact of the performance degradation. 2. Initiating comprehensive monitoring and logging across relevant infrastructure components, network devices, servers, storage. 3. Analyzing both real-time and historical data to identify correlations between the performance issues and specific events or traffic patterns. 4. Formulating hypotheses based on the analyzed data and testing them systematically. 5. Implementing changes only after a clear root cause has been identified and validated, following a defined change management process. 6. Documenting all findings, actions, and resolutions. Question 14. The monitoring system demonstrates intermittent high-latency spikes affecting a critical application cluster, with no clear pattern correlating to specific user actions or scheduled maintenance. Network interface utilization on several leaf switches shows occasional, brief periods of near 100% saturation, but these spikes do not consistently align with the reported latency events. Application logs show no direct errors, but performance degradation is noted by end users during these periods. Which of the following troubleshooting approaches is the most appropriate initial step to identify the root cause? Option A. Analyze network traffic flow data and packet capture logs from the affected leaf switches and the application servers to identify potential congestion points, microbursts, or unusual traffic patterns. Option B. Immediately initiate a rolling reboot of the affected application servers to rule out any server-side resource contention. Option C. Implement aggressive quality of service (QoS) policies on the leaf switches to prioritize application traffic, assuming network congestion is the primary issue. Option D. Focus solely on reviewing the application's performance metrics and database query logs for any anomalies that might indicate a software bottleneck. The correct answer is A. Analyze network traffic flow data and packet capture logs from the affected leaf switches and the application servers to identify potential congestion points, microbursts, or unusual traffic patterns. Explanation. This scenario presents a common but challenging situation in data center operations. Intermittent, non-deterministic performance degradation. Professional challenge lies in isolating the root cause of the issue without impacting production services, especially when the problem is not consistently reproducible. This requires a systematic troubleshooting methodology, deep understanding of the data center infrastructure, and adherence to operational best practices. The regulatory framework for this exam, 300-615 DCIT, implicitly emphasizes operational stability, security, and efficient resource utilization, all of which are critical for maintaining a compliant and functional data center. The correct approach involves a methodical investigation that prioritizes non-disruptive diagnostics and leverages available tools to gather comprehensive data. This aligns with best professional practices by minimizing risk to ongoing operations and ensuring that any corrective actions are based on solid evidence. Specifically, focusing on network telemetry and traffic patterns is crucial because network performance is a foundational element of data center infrastructure. Identifying anomalies in packet loss, latency, or throughput can directly point to congestion, misconfigurations, or hardware issues within the network fabric, which are common culprits for application performance problems. This systematic data collection and analysis is essential for meeting implicit regulatory expectations of service availability and data integrity. An incorrect approach that immediately jumps to rebooting critical network devices without prior analysis is professionally unacceptable. This action, while sometimes a last resort, bypasses the diagnostic process and can lead to unintended consequences, such as extended downtime or data corruption, which could violate service-level agreements, SLAs, and potentially regulatory requirements for uptime and data protection. Another incorrect approach, such as solely relying on application logs without considering the underlying infrastructure, fails to acknowledge the interconnectedness of the data center. Application issues can often stem from network or storage problems, and ignoring these layers means missing the true root cause, leading to inefficient troubleshooting and prolonged outages. Furthermore, making configuration changes based on assumptions rather than data is a significant ethical and professional failure, as it introduces risk and can exacerbate the problem. The professional decision-making process for such situations should involve 1. Acknowledging and documenting the reported issue. 2. Gathering initial telemetry and logs from all relevant layers, network, compute, storage, application. 3. Forming hypotheses based on the initial data. 4. Prioritizing diagnostic steps that are least disruptive to production. 5. Executing diagnostics systematically, collecting further data at each step. 6. Analyzing the new data to confirm or refute hypotheses. 7. Implementing targeted remediation based on confirmed root cause. 8. Verifying the resolution and documenting the entire process. This structured approach ensures that troubleshooting is efficient, effective, and minimizes risk, aligning with the principles of responsible data center management. Question 15. Market research demonstrates that intermittent application performance degradation in a Cisco data center environment is a frequent and challenging issue for IT professionals. An engineer is tasked with resolving an issue where users report slow response times for a critical financial application, but the problem is not consistently reproducible. The engineer has access to application logs, network monitoring tools, and server hardware diagnostics, which troubleshooting approach is most likely to lead to an efficient and accurate resolution while adhering to best professional practices. Option A. Systematically investigate potential issues layer by layer, starting with physical connectivity and link status, then moving to network device configurations and traffic flows, followed by server hardware health, and finally application-level diagnostics. Option B. Begin by analyzing the application logs for specific error messages and performance bottlenecks, then proceed to examine server resource utilization, CPU memory, disk I/O, if application logs do not yield a clear cause. Option C. Focus on increasing the bandwidth of the network links serving the application servers and upgrading the application server's hardware, as these are common causes of performance degradation. Option D. Immediately initiate a rollback of recent application code deployments and network configuration changes, assuming one of these is the most probable culprit for the intermittent performance issues. The correct answer is B. Begin by analyzing the application logs for specific error messages and performance bottlenecks, then proceed to examine server resource utilization, CPU memory, disk I/O, if application logs do not yield a clear cause. Explanation. Scenario analysis. This scenario presents a common challenge in data center troubleshooting: intermittent performance degradation affecting critical applications. The difficulty lies in the elusive nature of the problem, making it hard to pinpoint the root cause. The pressure to restore service quickly, coupled with the potential impact on business operations, necessitates a systematic and thorough troubleshooting methodology. The challenge is amplified by the need to adhere to established operational procedures and potentially regulatory compliance requirements related to service availability and data integrity, even if not explicitly stated in the question's context, as best practices often align with such principles. Correct approach analysis. The correct approach involves a methodical, layered troubleshooting process, starting from the physical layer and moving up the OSI model. This aligns with industry best practices and the principles of effective network troubleshooting, which are implicitly expected in a professional data center environment. By systematically isolating potential issues at each layer, the engineer can efficiently narrow down the problem space. This approach minimizes disruption, reduces the risk of introducing new problems, and ensures that all potential causes are considered. It reflects a commitment to thoroughness and accuracy, which are paramount in maintaining a stable and reliable data center infrastructure. This methodical process also supports audit trails and incident reporting, which are often regulatory requirements for demonstrating due diligence and compliance. Incorrect approach is analysis. Focusing solely on application-level logs without investigating underlying network or hardware issues is an incomplete approach. This fails to consider that application performance issues can often stem from network congestion, faulty hardware, or misconfigurations at lower layers. This can lead to wasted time and resources chasing the wrong problem, delaying resolution, and potentially causing further service degradation. Ethically, this approach could be seen as negligent if it leads to prolonged downtime due to overlooking fundamental infrastructure problems. Implementing a broad, unverified configuration change across multiple devices without a clear hypothesis or testing plan is highly risky. This shotgun approach can introduce widespread instability, exacerbate the original problem, or create entirely new issues. It violates the principle of least privilege and controlled change management, which are critical for maintaining data center integrity and security. Regulatory frameworks often mandate change control processes to prevent such uncontrolled modifications. Ignoring potential hardware failures and focusing exclusively on software configurations is also a flawed strategy. Hardware issues, such as failing network interface cards, faulty transceivers, or overloaded power supplies, can manifest as intermittent performance problems. Neglecting these possibilities means the root cause may never be identified, leading to recurring issues and potential data loss or corruption. This oversight can have significant implications for business continuity and data integrity, which are often subject to regulatory oversight. Professional reasoning. Professionals should adopt a structured troubleshooting methodology, such as the OSI model or a similar layered approach. This involves gathering information, forming hypotheses, testing those hypotheses systematically, and documenting findings at each step. When faced with intermittent issues, it's crucial to consider all potential layers of the infrastructure, from physical cabling to application logic. Prioritize changes based on risk and impact, and always test in a controlled manner. Maintaining clear communication with stakeholders and adhering to established operational procedures and change management policies are essential for effective and responsible troubleshooting. Question 16. Regulatory review indicates that data center infrastructure performance issues must be addressed with a methodology that prioritizes service continuity and data integrity. A critical application is experiencing intermittent latency spikes, impacting user experience. The network team is tasked with identifying the root cause. Which troubleshooting approach best aligns with these regulatory mandates and professional best practices for data center infrastructure? Option A. Immediately implement a series of broad network configuration changes across multiple switches and routers in the affected data center segment, hoping to resolve the latency issue through trial and error. Option B. Randomly restart network devices in the suspected area of the data center without prior analysis or documentation to see if the issue resolves itself. Option C. Begin by examining the application logs and user reports to understand the symptoms. Then proceed to analyze the network connectivity and performance metrics from the application servers outwards, progressively investigating the network path and infrastructure components. Option D. Focus exclusively on the application code and database performance, assuming the network infrastructure is functioning optimally and is not a contributing factor to the latency. The correct answer is C. Begin by examining the application logs and user reports to understand the symptoms. Then proceed to analyze the network connectivity and performance metrics from the application servers outwards, progressively investigating the network path and infrastructure components. Explanation. This scenario presents a common challenge in data center troubleshooting, a performance degradation impacting critical services, with the root cause not immediately apparent. The professional challenge lies in efficiently diagnosing the issue while adhering to established operational procedures and regulatory compliance, particularly concerning data integrity and service availability. The need for a systematic approach is paramount to avoid introducing further instability or violating service level agreements, SLAs, which often have regulatory implications. The correct approach emphasizes a methodical, layered troubleshooting methodology, starting with the most fundamental aspects of the network infrastructure and progressively moving up the stack. This aligns with best practices for network diagnostics and is implicitly supported by regulatory frameworks that mandate robust and reliable data center operations. By isolating the issue to a specific layer or component, the engineer can efficiently pinpoint the root cause without unnecessary disruption. This systematic process ensures that troubleshooting steps are documented, repeatable, and auditable, which is crucial for compliance and post-incident analysis. Incorrect approaches fail to adhere to this structured methodology, One incorrect approach might involve making broad, sweeping configuration changes across multiple devices without a clear hypothesis or isolation strategy. This is professionally unacceptable as it increases the risk of unintended consequences, exacerbates the problem, and makes root cause analysis significantly more difficult. From a regulatory perspective, such an approach could lead to a violation of data integrity or availability mandates if the changes result in data loss or prolonged service outages. Another incorrect approach might be to focus solely on application-level symptoms without investigating the underlying network infrastructure. This is a failure of professional due diligence, as network performance is a critical dependency for application functionality. It also risks violating regulations that require comprehensive incident response and resolution, not just superficial fixes. The professional reasoning process for such situations should involve 1. Clearly defining the problem and its impact. 2. Formulating a hypothesis based on initial observations. 3. Developing a troubleshooting plan that prioritizes least disruptive and most effective steps. 4. Executing the plan systematically, documenting each step and its outcome. 5. Escalating or seeking assistance when necessary. 6. Verifying the resolution and performing a post-incident review to identify preventative measures. This structured approach ensures efficiency, minimizes risk, and maintains compliance with operational and regulatory requirements. Question 17. The risk matrix shows a high likelihood of a critical network outage due to a misconfiguration in the data center's routing protocols. Which troubleshooting approach best aligns with professional best practices and regulatory expectations for maintaining data center infrastructure stability and compliance? Option A. Make multiple, simultaneous configuration adjustments across various routing devices to expedite the resolution process. Option B. Immediately revert to the last known good configuration to restore service as quickly as possible, deferring root cause analysis to a later time. Option C. Systematically isolate the misconfiguration by analyzing logs, verifying routing table entries, and implementing a single, targeted change with thorough validation before and after. Option D. Engage a third-party vendor to remotely access the network and perform an emergency fix without detailed internal oversight. Correct answer is C. Systematically isolate the misconfiguration by analyzing logs, verifying routing table entries, and implementing a single, targeted change with thorough validation before and after. Explanation. The risk matrix shows a high likelihood of a critical network outage due to a misconfiguration in the data center's routing protocols. This scenario is professionally challenging because a misconfiguration can have cascading effects, leading to significant business disruption, data loss, and financial penalties. The pressure to restore service quickly can lead to hasty decisions, increasing the risk of further errors. Careful judgment is required to balance the urgency of resolution with the need for thoroughness and adherence to established procedures. The correct approach represents best professional practice because it prioritizes a systematic and documented troubleshooting methodology. This aligns with industry best practices and regulatory expectations for maintaining operational integrity and compliance. By isolating the issue, verifying changes, and documenting the process, the engineer ensures that the resolution is effective, repeatable, and auditable. This methodical approach minimizes the risk of introducing new problems and provides a clear record for post-incident review, which is crucial for continuous improvement and meeting compliance requirements. An incorrect approach that involves immediately reverting to a previous known good configuration without proper analysis is professionally unacceptable. This bypasses the opportunity to understand the root cause of the misconfiguration, potentially leaving the underlying vulnerability unaddressed. This could lead to recurring issues and a failure to meet the organization's duty of care in maintaining a stable and secure infrastructure. Furthermore, it may violate internal change management policies and audit trails, which are often mandated by regulatory frameworks to ensure accountability and traceability of network changes. Another incorrect approach, such as making multiple simultaneous configuration changes in an attempt to quickly resolve the issue, is also professionally unacceptable. This violates the principle of isolating variables during troubleshooting, making it impossible to determine which change, if any, resolve the problem. This haphazard method increases the likelihood of introducing new, unforeseen issues and makes rollback procedures complex and error-prone. It demonstrates a lack of discipline and adherence to best practices for network management and troubleshooting, potentially leading to extended downtime and increased risk. The professional decision-making process for similar situations should involve 1. Acknowledging the urgency but not succumbing to pressure. 2. Initiating a structured troubleshooting process, starting with data gathering and hypothesis formation. 3. Implementing changes one at a time with clear verification steps after each change. 4. Documenting all actions, observations, and outcomes. 5. Consulting with colleagues or subject matter experts if progress stalls. 6. Performing a post-incident review to identify lessons learned and update procedures. This systematic approach ensures that issues are resolved effectively, efficiently, and in a manner that upholds professional standards and regulatory compliance. Question 18. Process analysis reveals intermittent packet loss and increased latency, affecting a critical application hosted within a Cisco data center. The issue is reported by users as sporadic and not tied to specific times of day. The network infrastructure includes Nexus switches, ACI fabric, and various Cisco UCS servers. The IT team has been unable to consistently reproduce the problem in a controlled environment. What is the most effective initial troubleshooting approach to systematically diagnose the root cause of this intermittent performance degradation? Option A. Begin replacing network interface cards, NIC, on the affected Cisco UCS servers and individual Nexus switch port modules, as hardware failure is the most probable cause of intermittent issues. Option B. Analyze traffic flow patterns and congestion points within the ACI fabric using the ACI APIC controller and monitor key performance indicators, KPI, on Nexus switches, such as interface error counters, buffer utilization, and CPU load. Concurrently, examine the Cisco UCS server logs for any application-level errors or resource contention that might correlate with the reported performance issues. Option C. Focus solely on gathering more anecdotal evidence from end users to identify specific times or actions that trigger the performance degradation, without performing any technical network diagnostics. Option D. Immediately initiate a full network topology reconfiguration of the ACI fabric to optimize traffic paths, assuming the current configuration is the source of the intermittent issues. The correct answer is B. Analyze traffic flow patterns and congestion points within the ACI fabric using the ACI APIC controller and monitor key performance indicators, KPI, on Nexus switches, such as interface error counters, buffer utilization, and CPU load. Concurrently, examine the Cisco UCS server logs for any application-level errors or resource contention that might correlate with the reported performance issues. Explanation. This scenario presents a common challenge in data center operations: intermittent network performance issues that are difficult to pinpoint. The professional challenge lies in the need to systematically isolate the root cause without disrupting critical services or introducing new problems. This requires a deep understanding of data center network protocols, troubleshooting methodologies, and the ability to correlate various data points. Careful judgment is required to prioritize troubleshooting steps, considering the potential impact on business operations and the need for accurate diagnosis. The correct approach represents best professional practice because it follows a structured, logical troubleshooting methodology. It begins with gathering information and understanding the scope of the problem, then moves to verifying the physical layer, followed by examining the logical configuration and traffic flow. This systematic approach minimizes the risk of misdiagnosis and ensures that all potential causes are considered in a prioritized manner. Adhering to established troubleshooting frameworks, such as those outlined by Cisco for DCIT, is crucial for efficient problem resolution and aligns with industry best practices for maintaining data center stability and performance. An incorrect approach that immediately focuses on reconfiguring complex routing protocols without a clear understanding of the symptoms or impact is professionally unacceptable. This could lead to further network instability, extended downtime, and a more complex troubleshooting situation. It bypasses essential diagnostic steps and risks introducing new issues. Ethically, it demonstrates a lack of due diligence and a disregard for the potential impact on services. Another incorrect approach, such as solely relying on end-user reports without independent verification or data collection, is also professionally unsound. While user feedback is valuable, it is often subjective and may not accurately reflect the underlying technical issue. Without objective data, troubleshooting becomes speculative and inefficient. This approach fails to meet the professional obligation to thoroughly investigate and diagnose the problem using technical means. A third incorrect approach, such as immediately replacing hardware components without evidence of failure, is wasteful and inefficient. This can lead to unnecessary expenditure and may not resolve the issue if the problem lies in configuration or software. It demonstrates a lack of analytical rigor and a failure to follow a diagnostic process. The professional reasoning process for such situations should involve 1. Clearly defining the problem and its impact. 2. Gathering all available information including logs, monitoring data, and user reports. 3. Formulating a hypothesis about the potential cause. 4. Developing a step-by-step troubleshooting plan starting with the simplest and most likely causes. 5. Executing the plan methodically, documenting each step and its outcome. 6. Analyzing the results and refining the hypothesis or moving to the next troubleshooting step. 7. Verifying the resolution and documenting the solution to prevent recurrence. Question 19. Implementation of a new storage array in a Cisco data center fabric has coincided with intermittent packet loss and increased latency for critical virtual machines hosted on a specific cluster. The network team has been alerted to the issue. What is the most effective initial troubleshooting approach to diagnose the root cause? Option A. Initiate a series of random reboots of the Cisco Nexus switches in the data center fabric to see if the issue resolves itself. Option B. Review the application logs of the affected virtual machines for any error messages related to storage access or network connectivity. Option C. Verify the physical connectivity and link status of all network interfaces involved in the path between the affected VMs and the storage array, and check for interface errors or discards on the relevant Cisco Nexus switches. Option D. Immediately analyze the configuration of the new storage array's network interfaces and its interaction with the fiber channel over Ethernet, FCO-E, or I-SCSI configuration on the Cisco Nexus switches. The correct answer is C. Verify the physical connectivity and link status of all network interfaces involved in the path between the affected VMs and the storage array, and check for interface errors or discards on the relevant Cisco Nexus switches. Explanation. The scenario presents a common challenge in data center operations: unexpected network performance degradation impacting critical applications. The professional challenge lies in quickly and accurately identifying the root cause without causing further disruption, while adhering to established operational procedures and potentially regulatory compliance requirements for service availability. The need for a systematic troubleshooting approach is paramount to avoid guesswork and ensure a repeatable, effective resolution. The correct approach represents best professional practice because it prioritizes a structured, evidence-based methodology. By starting with the most likely and impactful areas, physical layer and basic connectivity, and progressively moving to more complex layers, it minimizes the risk of overlooking simple issues or introducing new problems. This methodical progression aligns with industry best practices for network troubleshooting, often implicitly or explicitly supported by operational guidelines and service-level agreements, SLAs, that mandate timely and effective problem resolution. In a regulated environment, demonstrating a diligent and documented troubleshooting process is crucial for auditability and compliance with service continuity mandates. An incorrect approach that immediately jumps to complex configuration changes without verifying the fundamentals is professionally unacceptable. It risks exacerbating the problem, wasting valuable time, and potentially violating operational procedures that require a phased troubleshooting methodology. Such an approach demonstrates a lack of systematic thinking and could lead to a failure to meet SLA commitments, which may have contractual or regulatory implications depending on the data center's operational context and the services it supports. Another incorrect approach, focusing solely on application-level logs without considering the underlying network infrastructure, is also professionally flawed. While application issues can manifest as performance problems, neglecting the network layer means ignoring a primary potential cause. This can lead to misdiagnosis and prolonged downtime, which is detrimental to service availability and could breach operational responsibilities. A third incorrect approach, involving random device reboots without a clear hypothesis or understanding of the potential impact, is highly unprofessional and risky. This is a brute force method that can disrupt other services and obscure the actual root cause by altering the system state. It demonstrates a lack of analytical skill and a failure to follow established change management and troubleshooting protocols, which are essential for maintaining a stable and compliant data center environment. The professional decision-making process for similar situations should involve 1. Clearly defining the problem and its impact. 2. Gathering initial symptoms and available data. 3. Formulating a hypothesis based on the symptoms. 4. Developing a systematic troubleshooting plan starting with the most probable and least disruptive causes. 5. Executing the plan methodically, documenting each step and its outcome. 6. Escalating or seeking assistance if the problem persists. 7. Verifying the resolution and implementing preventative measures. Question 20. Operational review demonstrates intermittent packet loss on a critical data center network segment, impacting application performance. The network team suspects a potential configuration issue on a core switch, but lacks definitive evidence. What is the most appropriate next step to address this issue while ensuring regulatory compliance and operational integrity? Option A. Immediately implement a rollback of the most recent configuration change on the suspected switch, assuming it is the cause, and monitor for improvement. Option B. Initiate a deep packet inspection capture on the affected segment, correlate findings with system logs and performance metrics, and then propose a targeted configuration adjustment based on documented findings and within the change control framework. Option C. Apply a known good configuration backup to the suspected switch without further analysis, as this has resolved similar issues in the past. Option D. Advise application owners to temporarily reduce traffic load to mitigate the symptoms until a full investigation can be conducted at a later, less critical time. The correct answer is A. Immediately implement a rollback of the most recent configuration change on the suspected switch, assuming it is the cause, and monitor for improvement. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations where a critical infrastructure component is experiencing intermittent performance degradation. The professional challenge lies in balancing the immediate need to restore full functionality with the imperative to adhere to established operational procedures and regulatory compliance, particularly concerning data integrity and service availability. The intermittent nature of the issue adds complexity, making it difficult to pinpoint the root cause without potentially exacerbating the problem or introducing new risks. A hasty, unverified solution could lead to data corruption, extended downtime, or security vulnerabilities, all of which have significant regulatory and business implications. Correct approach analysis. The correct approach involves a systematic, documented troubleshooting methodology that prioritizes data integrity and compliance with established change management processes. This includes thorough log analysis, correlation of events across different system components, and controlled testing in a non-production environment or during a scheduled maintenance window. Adhering to the documented troubleshooting runbooks and change control procedures ensures that any remediation steps are auditable, repeatable, and have been vetted for potential impact. This aligns with regulatory requirements for operational resilience, data protection, and incident management, which mandate that changes to critical infrastructure be managed to minimize risk and ensure accountability. The focus on evidence-based decision-making and adherence to established protocols is paramount for maintaining a compliant and reliable data center environment. Incorrect approaches analysis. Implementing a configuration change without proper validation or documentation is a significant regulatory and ethical failure. This bypasses change control procedures, which are often mandated by regulations like SOX, if applicable to the jurisdiction, or industry best practices for IT governance. Such an action creates an unrecorded deviation from the standard operating environment, making it impossible to audit the change, understand its impact, or revert it effectively if it causes further issues. This directly compromises data integrity and service availability, potentially leading to non-compliance with service-level agreements, SLAs, and data protection mandates. Applying a quick fix or a workaround without understanding the underlying cause is also professionally unacceptable. While it might temporarily alleviate the symptom, it fails to address the root problem, increasing the likelihood of recurrence and potentially masking a more serious underlying issue. This approach neglects the due diligence required for comprehensive problem resolution and can lead to cascading failures. From a regulatory standpoint, it demonstrates a lack of proactive risk management and a failure to maintain the system in a state that ensures ongoing compliance and operational stability. Ignoring the issue until it escalates further is a critical failure in operational responsibility and regulatory compliance. Data center infrastructure is subject to various compliance frameworks that require timely detection, diagnosis, and resolution of performance issues to ensure data integrity and service continuity. Delaying action can lead to data loss, extended service outages, and potential breaches of regulatory obligations related to availability and security. This passive approach signifies a disregard for the operational health of the data center and the associated compliance requirements. Professional reasoning. Professionals in data center operations must adopt a structured, evidence-based approach to troubleshooting. This involves leveraging available tools for monitoring and logging, meticulously documenting all steps taken, and adhering to established change management and incident response protocols. When faced with intermittent issues, the decision-making process should prioritize understanding the root cause over immediate symptom relief. This involves correlating events, consulting documentation and vendor support, and performing controlled tests. Any proposed solution must be evaluated against its potential impact on data integrity, service availability, and security, and must follow the organization's change control process. This disciplined approach ensures not only operational efficiency, but also robust regulatory compliance and ethical conduct.